Access control lists, or ACLs, are challenging for many networkers. This video has two purposes. First, we will look at some ACL basics to orient ourselves. Then, we will present one part of ACL configuration that often baffles beginners, the wildcard mask. Knowing how to configure ACLs is one of the most important skills that a networker can learn because they have a direct impact on the security of a network. Before we get started, understand that this video will use a standard ACL example. Therefore, we will focus on the source address of any packets we use in the examples. ACLs are groups of statements that enable networkers to permit or deny traffic. ACLs can be very short and simple or very long and complex. Here we will focus on a small, simple ACL so we can make sure to learn the concepts. This is a very simple ACL. The number 2 signifies to us that this is a standard ACL. Because this is a standard ACL, we know that it filters traffic based upon the source address of packets. So this ACL tells the router to permit traffic with a source address of 192.168.10.0. When we look at the 192.168.10.0 address, we should recognize this as a Class C network address. But this network address tells us nothing about which of its hosts to permit. Do we permit all the hosts on the network? Only hosts with odd host addresses? Does this represent a full 254 host network or just the first subnet of a /26 networking scheme? Wildcard masks help us to answer these questions. The wildcard mask is a series of ones and zeros that helps us determine which bit positions must match between addressing information in a data packet and the addressing information specified in the ACL. A 0 in a wildcard mask means that the bit values must match. A 1 in the wildcard mask means that the bit values can be ignored. If all necessary bit values match between the source IP address in the data packet and the address specified in the ACL, then the action specified in the ACL, the permit or deny, is executed on the packet. Recall that an IP packet includes both source and destination IP address fields. This information is used by the ACL to determine whether or not a packet is acted upon. Again, for this example, we are only concerned with the source IP address since we are working with a standard ACL, which filters only on source IP address. Other more complex ACLs use more information, but we're keeping it simple here. Our ACL specifies a permit action for packets with a source address of 192.168.10.0 with a wildcard mask of 0.0.0.255. Knowing that in a wildcard mask, a 0 means that corresponding bit values must match, and a 1 means to ignore the corresponding bit values in the address, we can see that we are permitting any packet with a source address within the 192.168.10.0/24 network. Let's examine this closer. In green, we have the source address of the data packet entering or leaving a router. 192.168.10.35, for example. We can easily see that this source address is within the 192.168.10.0/24 network and thus would be permitted by the router. But let's look at what the router does to figure out if the data packet's source address matches that which is specified in the ACL. The leftmost 0 in the wildcard mask means that the leftmost bit position in a data packet's source address must match the leftmost bit position of the address in the ACL. It does. As we work our way across the first 24 bits, we see that the first 24 bits of the packet's source IP address match those in the ACL address, which is what is specified by the wildcard mask. As for the final 8 bits of the source address, they can be anything because the wildcard bit values for those bit positions are 1s, which means those bit positions can be ignored. So what we have here is a data packet whose source address matches the address specified in the ACL. Therefore, the ACL will perform a permit action on this packet. Now that we have reverse engineered a wildcard and how it operates in an ACL, let's see if we can develop one of our own. This is a classic example used to aid in understanding wildcard mask development. In this example, we will develop a wildcard mask to be paired with a network address. This combination is then used to develop ACLs to either permit or deny packets with source addresses in the numerical upper half of the 192.168.10.0 network. Consider the 192.168.10.0/24 subnet. If we were to split this in half, the lower half would have a range of 192.168.10.0 through 127, and the upper half's range would be 192.168.10.128 through 255. When developing the wildcard and address pair to specify the upper half of the subnet, we begin by specifying the address to be in the ACL. In this case, since we wish the ACL to act upon source IP addresses in the numerical upper half, the address in the ACL needs to be the beginning address of the upper half, which is 192.168.10.128. We then ask ourselves which bit positions must match between a packet's source address and the address contained in the ACL in order for the ACL to act upon a packet. We know that the first 24 bits, 192.168.10, must match. Now let's look at the rest of the address. The numerical upper half of the 192.168.10.0/24 network is the range 192.168.10.128 through 192.168.10.255. If we were to list in binary format the last octet of that range, it would look like this. Since we want to specify the numerical upper half of the subnet, we know that all addresses in that upper half will be equal to or higher than 128. What bit value do all the numbers in the range have in common? The first bit. Therefore, the first 25 bits between the ACL address and the packet's source address must match in order for the ACL to act upon the packet. Thus, we must assign those bit positions a 0 in the wildcard. The remaining bit positions of the packet's source address can be of any value, so we assign them a 1 in the wildcard mask. This results in a wildcard mask of 0.0.0.127. Whether or not the packet is permitted or denied depends upon what is specified in the ACL. To specify the lower half, all we need to do is change the address in our ACL from 192.168.10.128 to 192.168.10.0. We can keep the same wildcard. By changing the last number in the ACL address from 128 to 0 and using the same wildcard to specify the first bit position in the last octet must match, we are no longer matching a binary 1. We are matching a binary 0. If we match a 0 in the first bit position of the last octet, and the remaining positions can be any value, the number is guaranteed to be 0 through 127, which is the lower half of the subnet. Remember, the wildcard masks that are contained in ACL statements are used to determine if a packet's addressing information matches that in the ACL statement. If it does, then the ACL permits or denies that packet based on the rest of the ACL statement. Also remember, in this video we used a standard ACL and thus only presented information about a packet's source address. When using extended ACLs, source and destination addresses and protocols become part of the equation. We hope this video helps you to better secure your network through appropriately designed ACLs.